Okay, to continue our discussion of bonding, what we're going to do is take a closer look at what we refer to as ionic bonding. And we had mentioned a little bit about ionic bonding in an earlier podcast. Basically, what an ionic bond is a transfer of electrons. Now, it's important to understand that there isn't such thing as a 100% transfer of electrons, but that's the way we're going to treat it. So as we go through this vodcast, you always want to be thinking about what's giving up the electrons and what's taking the electrons. So let's take a look at our periodic table again and talk about what gives up electrons and what takes electrons. First of all, an ionic bond typically takes place between a metal and a nonmetal. And if you remember from previous podcasts, we said that things in the first column have one valence electron, so they want to get rid of one electron. Things in the second column want to get rid of two valence electrons, etc. So what we're going to look at primarily here are valence electrons being given up or taken, not necessarily too much with the electronegativity stuff. That is important, and it'll be more important when we talk about covalent bonds. Okay, so just as a review, remember everything in the first column has a +1 charge, +2 charge for everything in the second column, +3, we're going to skip the carbon column, -3, -2, and -1. And as you can see on this periodic table, the noble gases aren't included. Okay, first of all, let's talk about what lattice energy is. As we talk more and more about ionic bonding, what we're going to talk about is a lattice structure that they form, that these compounds form when they make a bond. And we're going to talk about that in much more detail a little bit later when we talk about solids, liquids, and gases. But for right now, you should know that lattice energy is it's the change in energy that takes place when separated ions are packed together to form an ionic solid. And so we have a standard, we say, when they're in the gaseous phase. Now, you don't really need to worry too much about this formula and what lattice energy means. Basically, what you should know is it's the amount of energy it takes to separate ions in a lattice structure. A lattice structure is the thing that forms when an ionic bond forms. You can take a little bit closer look at these constants in the formula, but basically what it says is that energy is going to be equal to the charge on the one thing, let's just say it's +1, the charge on the other ion, let's say it's -2, and then the distance between them. So let's take a look at how compounds come together to form an ionic bond. When you form an ionic bond, we need a metal and a nonmetal. So we're going to use magnesium as our metal and chlorine as our nonmetal. The first step in this process is looking at magnesium, realizing it has two valence electrons. So I'm going to put a dot here representing the one valence electron and a dot here representing the other one. And we talked about this a little bit earlier in a previous podcast. Chlorine has 7 valence electrons, so 1, 2, 3, 4, 5, 6, 7. And we'll talk about how you pair these up a little bit later. Okay, so we said magnesium wants to obtain an octet, so what it's going to do is get rid of these 2 valence electrons, so its second energy level will be full. So magnesium is going to get rid of 1 valence electron. Chlorine is going to take that valence electron because if it takes an electron, it will have a full outer shell. So when this transfer takes place, that electron is going to be there, and as you can see, chlorine has a full outer shell. Well, we still have 1 valence electron with magnesium. So if we have another chlorine atom, 1, 2, 3, 4, 5, 6, 7 valence electrons, that electron can be transferred from magnesium to chlorine, or to this chlorine ion. Okay, so once magnesium gets rid of its 2 electrons, it has a +2 charge. And once each chlorine ion takes an electron, they're each going to have a 1- charge. This is important. The overall charge of the compound has to be 0. So if we have 2 chlorine ions and 1 magnesium ion, the overall charge on the magnesium is 2 plus. The charge on each chlorine is 1 minus, but since we have 2 of them, it's 2 minus. So the formula for magnesium chloride is MgCl2. So what that means is that magnesium and 2 chlorine ions will come together to form what we call a formula unit or an ionic compound. The formula unit tells you the lowest whole number ratio of the ions in the compound. And remember, positive ions we call cations, negative ions we call anions. So what the formula for an ionic compound tells you is the lowest whole number ratio of ions in the lattice structure. Okay, so let's take a look at aluminum and fluorine. If you look at your periodic table, you know that aluminum has 3 valence electrons. Fluorine has 7 valence electrons, just like chlorine. So what we're going to do is transfer 1 to that fluorine, and as you can tell, we're going to need 2 more fluorines. We'll transfer 1 to that one and 1 to that one. Once aluminum gets rid of its 3 electrons, it has a 3 plus charge. Each fluorine has a 1 minus charge, so as we know, the formula is going to be AlF3. Now again, what that tells you is the lowest whole number ratio of ions in the lattice structure. Okay, that is a very brief introduction to ionic bonding. And again, as we move through this course, we're going to talk about ionic bonding in much more detail. But basically what you should understand about ionic bonding is that it's a transfer of electrons between a metal and a nonmetal. The metal will form a cation, the nonmetal will form an anion. The overall charge of the compound when the 2 ions come together has to be 0, so we need a ratio of ions to make the overall charge 0. What that formula tells you for the ionic bond is the lowest whole number ratio of ions in the lattice structure.